Alright, so it says a billiard ball moving at 2 meters per second rolls off a horizontal table that is 1.5 meters above the ground. How long does it take to hit the floor? How far away from the base is it moving? And what is its final resultant velocity? Alright, so this is very similar to the sample question that we did in class. I'm going to draw it out. Alright, so here's my table. I know that the table is 1.5 meters high. So 1.5 meters goes in there. I know that this billiard ball is up here and it's projected horizontally off the table at 2 meters per second, and it's going to do something like this and end up over here. I'm concerned about how long it's in the air for, how far away from the base it lands, and its final resultant velocity when it hits the floor. So the first thing I want to do when I see any of these things is I want to make two columns. I'm going to have horizontal things and I'll make vertical things, and I'll make them two different colors so we can keep track. Horizontally, I know this velocity is 2 meters per second. I am looking for the distance that it lands horizontally away. That's my question mark. And I am going to look for time eventually, so I'll make that t. In the vertical direction, I know that because it's moving completely horizontally, its initial vertical speed is 0. It's in free fall, so it's going to accelerate at negative 9.8 meters per second squared. And it's going to fall a distance of negative 1.5 meters. Again, the negative sign because it's falling downwards. I'm going to need to find time, and I'm going to need to find the velocity at which this thing hits the floor in order to find out its resultant velocity. Let's find time first. So I'm going to use d equals v naught t plus 1/2 a t squared. I have negative 1.5 equals 0 plus 1/2 negative 9.8 t squared. I have negative 1.5 equals negative 4.9 t squared. 1.5 divided by 4.9 is 0.3. Take the square root of that number and I get 0.55 seconds. Once I find t, I can put t up here. Since the horizontal motion is a constant velocity motion, I know that v equals xt. V being 2 meters per second, x being what I'm looking for. Oh, sorry. V equals x over t, so I have x over 0.55 seconds. I'm going to multiply that by 2, and I know it travels a distance horizontally, which I called x, of 1.1 meters. And then the last question is, what is the object's resultant final velocity? I know that as part of this, it has a horizontal speed of 2 meters per second. That does not change, that stays the same. And I need to find its vertical velocity to add to the component so I can find its resultant. I'm going to say that v equals v naught plus a t. V naught vertically was 0, a is negative 9.8, t is 0.55, so I multiply those two together, and I get the final velocity is negative 5.39. Good thing it's negative, that means it's on the way downwards, which agrees with what I'm talking about over here. My resultant goes from the start to the finish, which is Pythagorean's theorem. So I know that this resultant velocity is going to be the square root of 2 squared plus 5.39 squared. I can ignore the negative sign because when I square something it goes away anyway. So that's squared plus 4, take the square root of that, and I get the resultant velocity is 5.7 meters per second. And if I wanted to be perfectly 100% correct, I would find the angle 2, which is the inverse tangent of the opposite side, which is the 5.39, over the adjacent side. So the inverse tangent of 5.39 over 2, and I get an angle of 70 degrees. And so I would probably call that 70 degrees below, it's this, so it's 70 degrees below the horizontal. So my final answer would be 5.7 meters per second, 70 degrees below horizontal.